Hi friends, my name is Nandita. I am from Andhra Pradesh.
Good morning dear students. Today we are going to discuss about acids, bases and salts from chapter 2, class 10 CBSE syllabus. Children, you have learnt in your previous classes that the sour and bitter taste of food are due to acids and bases respectively present in them. If someone in the family is suffering from a problem of acidity after overeating, which of the following would you suggest as a remedy? Lemon juice, vinegar or baking soda solution. Why everything tastes so differently? Why lemon is tangy and mango is sweet? This is because of different percentages of acids, bases and salts in their chemical composition. Children, we all have heard that the term acids, bases and salts and often used them in our daily life, complained about the acidity nature of food components. Used soap and ammonia for cleaning or heard about salt being created from seawater. Gaining a through understanding of acids, bases and salts, class 10 is essential for understanding basic chemistry and acids, bases and salts are the main chemical compounds that exist in our surrounding. Acids, bases and salts are components that occur naturally and can also be created artificially. They are found in various substances including our food. Vinegar or acetic acid is used as a food preservatives. Citric fruits have citric acid and etc. Children, other than food, they have also a wide varieties of uses such as in various industries, manufacturing plants, processing plants, laboratories and others. In this article, we will learn about acids, bases and salts and their properties, types, uses and others in detail. Children, in this video, we'll learn about the definition, characteristics and properties of acids, bases and salts. Let's learn how this can be characterized, understanding the concept of Arrhenius and Bronsted, Lowry and Lewis, etc. Children, let us discuss the definition of acids, bases and salts. Earlier, acids, bases and salts were characterized by the experimental testing of their aqueous solutions. An acid is defined as a substance whose water solution tastes sour, turns blue, litmus red and neutralizes bases. A substance is called base if its aqueous solution tastes bitter and turns red, litmus blue or neutralizes acids. Salt is a neutral substance whose aqueous solution does not affect litmus. According to Faraday, acid, bases and solutions are termed as electrolyte. Further, Liebig proposed that the acids are compounds which can hydrogen that can be replaced by metals. Children, let us discuss in detail about acids. Acids are those what when dissolved in water given hydrogen ions, or we can write hydronium ion H3O+. This hydronium ion is formed due to the combination of hydrogen ion produced by acid with water molecule. Acidity is a characteristic property of acids. Acidic substances are usually very sour. In fact, the word acid and acidity are derived from Latin word aciduous, which means sour. If you dip a blue litmus paper into an acid, it will turn red, while a red litmus paper will not change color. Acids also liberate dihydrogen when they react with some metals. Children, let us discuss in detail what are acids. Acids are a type of chemical substance that is characterized by their ability to donate hydrogen ions when dissolved in water. Acids can be found naturally in many foods and beverages including citrus, fruits, vinegar and fermented products, and they also used in various industrial processes. Here are some key points about acids. Children, acids can be classified into two categories: organic acids, which derived from living organisms, and inorganic acids, which are derived from non living sources. Acids have a sour taste and can cause a tingling or burning sensation on the tongue or skin. The strength of an acid is determined by its pH value, which ranges from 0 to 14. Acid with a pH less than 7 are considered to be acidic, while those with a pH greater than 7 are basic or alkaline. Children, acids can be react with bases to form salts and water in a process called neutralization. Acids are used in a variety of industrial applications such as the production of fertilizers, dyes, and pharmaceuticals. Some acids can be harmful or corrosive to living tissue such as hydrochloric acid, which is found in the stomach and it is necessary for digestion, but can cause severe burns if it comes into contact with the skin. Acids also used in various chemical reactions such as in the production of polymers and plastics as well as in the cleaning and sterilization of medical equipment. Children, here are some of the examples. Acids are hydrochloric acid, sulfuric acid, nitric acid, phosphoric acid and carbonic acid. Children, let us discuss the classification of acids. We have a different classification based on their different factors. So let us sum up and make ourselves familiar with it. Depending on the source from which they are obtained, they are derived into organic acids and inorganic acids. Organic acids are obtained from plants and animals, or where we can say they are present in organic matter. Inorganic acids, these are those that are obtained from minerals present in the earth. These are quite reactive in nature. We have citric acid and sulfuric acids are example for these inorganic acids. Children, now let us discuss the physical properties of acids. Acids are chemical substances that they have unique physical and chemical properties. Here are some of the physical properties of acids. Acids have a sour taste. Most acids have a distinctly sour taste, such as lemon juice and vinegar. Acids change the color of indicators. Acids change the color of indicators such as litmus paper, which turns red in the presence of an acid. Acids are corrosive. Many acids are corrosive and can use damage to living tissues or corrode metal and other materials. Acids have a low pH. pH scale measures the acidity of alkalinity of a solution, which a pH of 7 being neutral and low pH values indicating greater acidity. Acids typically have a pH of less than 7. Acids react with bases to form salts and water. When an acid reacts with a base, the substance neutralize each other, form a salt and water. Acids have a higher boiling point than water. Yes, acids generally have a higher boiling point than water, which means that they are require more energy to boil than water. Acids are good conductors of electricity. In a solution, acids can conduct electricity because they contain charged particles known as ions. Children, acid is a compound which fields hydrogen ion when dissolves in water, and acid is a sour to taste and it is a corrosive in nature. The pH of acids is less than 7. All the acids are react with metals to release hydrogen gas. Example, zinc metals react with hydrochloric acid to form zinc chloride and hydrogen gas. When acids react with limestone, it produces carbon dioxide. Example, HCl reacts with limestone to produce carbonic acid and calcium chloride. Acids are classified into organic and inorganic acid. The best examples of organic acid is acetic acid, and inorganic acids are those which are produced from minerals, for example sulfuric acid, hydrochloric acid. Acids usually convert blue litmus paper to red litmus papers. Acids have a tendency to quickly corrode than the metal surfaces. Children, on the basis of number of hydrogen ions, acids can be classified as monoprotic acid. They can be produced one molecule of hydrogen H plus ions per one molecule of acid HCl. Next one is diprotic acid. They can produce 2 moles of H plus ions where 1 mole of acid H2SO4H. Triprotic acid. They produce 3 moles of H ions where 1 mole of acid on the basis of strengths to donate hydrogen ions. Based on this, acids can be classified as strong acids. These acids get completely 100% ionized in the aqueous solution. Thus, at equilibrium, the concentration of acid molecules becomes very less and concentrated of hydrogen ions reaches to maximum. For example, HCl, HNO3 and HClO4. Weak acids. Weak acids are only partially ionized in solution at equilibrium state. At equilibrium state, molecules of acid are present in a considerable amount and the concentration of hydrogen ions is less. For example, HFCH3COOH. Children, let us discuss the chemical properties of acid. Acid has various chemical properties. Few of the following chemical properties of acid include reaction of acids with metal. When an acid reacts with a metal, it produces hydrogen gas and the corresponding salt. Already we discussed that. When hydrochloric acid combines with zinc metal, it produces hydrogen gas and zinc chloride. Then reaction of acids with metal carbonate. When acids react with metal carbonates, they produce carbon dioxide gas and salts as well as waters. Example, the hydrochloric acid combines with sodium carbonate. It produces carbon dioxide gas, sodium chloride and water. Reaction of acid with hydrogen carbonates or bicarbonates. When acids react with metal hydrogen carbonates, they produce carbon dioxide gas, salt and water. Example, sulfuric acid gives sodium sulfate, carbon dioxide gas and water when it reacts with sodium bicarbonate. Children, now let us discuss about types of acids. Acids are classified into different categories. The classification of acid is discussed below in the article. On this basis of occurrence, acids are subdivided into two categories. One is natural acid, second one is mineral acid. Natural acid. Natural acids, often known as organic acids, there are acids derived from natural sources. For example, methanoic acid, acetic acid, oxalic acid, etc. Now let us discuss about mineral acids. Mineral acids are bases that are created from minerals. Inorganic acids, man-made acids and synthetic acids are the examples of mineral acids. And some of the examples like hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, phosphoric acid, etc. Children, on the basis of concentration, even acids can be categorized too. We discussed that strong and weak. Strong acid is an acidic that is totally ionized in water and produces H+, for example, hydrochloric acid, sulfuric acid and nitric acid. Weak acids. A weak acid is partially ionized in water, created a tiny amount of hydrogen ions H+, for example, acetic acid, carbonic acid, etc. Children, now let us discuss the uses of acids. Acids have various uses. Some of the important uses of acids are here below. Hydrochloric acid. Hydrochloric acid is used in different industries for heating applications. This acid is applied to remove deposits from the inside of the boiler. It is also used to clean silver waves and sinks. Sulfuric acid. Sulfuric acid is used to manufacture paints, dyes, drugs and fertilizers. In batteries, sulfuric acid is commonly utilized. This acid is typically found in the batteries used to start vehicles' motors. Sulfuric acid and nitric acid is used in the industrial production of dyes, explosives, paints and fertilizers. Nitric acid. Goldsmiths use nitric acids to clean gold and silver ornaments. Nitric acid is also used for manufacturing fertilizers. Orange and lemon juice contain a significant amount of citric acid. It can also be used for the food preservations. Acetic acid. Acetic acid can be used as a cleaning agent to clean windows, utensils, floor, etc. Acetic acid is an effective ingredient to enhance the flavor of food items. Acetic acid helps in the removal of stains from woodwork and carpets. Vinegar is a diluted solution of acetic acid that has a variety of uses in the home. It is mostly utilized in the food industry as a preservative. Acetic acid is used as a preservative in packaged foods such as sauce, ketchups, pickles, etc. Many soft drinks contain phosphoric acid as the main ingredient. Children, now let us discuss about bases. If we talk about bases, according to Arrhenius, there are those that when dissolved in water gives hydrochloric ion. Calcium hydrochloric ion and magnesium hydroxide are the examples of bases. Bases turn red litmus paper blue while the blue litmus paper stays blue. They taste bitter and also feel soapy. Some of the other common examples of the bases including sodium bicarbonate that is used in cooking and household bleach. Children, let us discuss in detail what are bases. Bases are chemical compounds that react chemically with acids. They produce salt and hydroxide ions in water. For example, potassium hydroxide, caustic potash, or KOH, calcium hydroxide, sodium hydroxide, etc. Children, now let us discuss the physical properties of bases. Bases have specific physical properties and they can easily be distinguished by their physical characters. Some physical properties of the bases are: bases, already we discussed, that has a bitter taste, they are soapy to touch. Base can change red litmus to blue. Aqueous solution of base conducts electricity. Bases are compounds that yield hydroxide ion when it is dissolved in water. Bases are bitter in taste and are corrosive in nature. They usually feel slippery and very soapy. Bases are good conductors of electricity and usually show a pH value of more than 7. Bases react with oils and grease to form molecules of soap. Bases convert red litmus paper to blue litmus paper. Bases also have the tendency of corrode the surface of metals. Children, let us discuss the strength of bases and strong of bases. They completely dissociates in water to give hydroxide ions. These bases totally dissociates and leave no dissociated molecule of base. They are the bases which are completely ionized in water to produce hydroxide ions. Example, all hydroxides of all reactive metals. Weak bases. They do not completely dissociates in water to give hydroxide ion. Already we discussed that these are the bases which are partially ionized and the equilibrium lies mostly towards the reactant side. Example, calcium hydroxide. Chemical properties of base. Bases have various chemical properties. Few of the chemical properties of bases are as follows. Reaction of base with metals. When alkali base reacts with metal, salt and hydrogen gas is produced. Example, when sodium hydroxide reacts with aluminum metal, sodium aluminate and hydrogen gas are generated. Reaction of non-metallic acids with base. Salt and water are formed when non-metallic oxides react with a base. Example, when calcium hydroxide reacts with carbon dioxide, calcium carbonate is formed along with water. Action of alkalis base with ammonium salts. Ammonia is produced when alkalis react with ammonium salts. Example, when calcium hydroxide reacts with sodium chloride, calcium chloride, water and ammonia are produced. Children, now let us discuss the types of bases. Acidity, concentration, and a degree of ionization are the three variables that can be used to classify bases. Based on the acidity, the number of hydroxyl ions presence determines acidity in bases. Based on the acidity, bases are classified into three categories, that are monoacidic, diacidic, and triacidic. Let us discuss about monoacidic. Monoacidic bases are those that contain only one hydroxyl ion and react with only one hydrogen ion. Monoacidic bases include NaOH, KOH, and others. Diacidic. Diacidic base is a base with two hydroxyl ions that reacts with two hydrogen ions, and CaHO2 and MgHO2 and other diacidic bases are examples. Triacidic acid. Triacidic base is a type of base that comprises three hydroxyl ions and three hydrogen ions. Based on their concentration, aqueous solution, bases are divided into two categories. One is concentrated bases, second one is diluted bases. Now let us discuss about concentrated bases. The concentration of a base in this type of bases is higher in the solution. For example, concentrated NaOH solution. Diluted. This type of bases have a lower concentration of base in their aqueous solution. For example, instant dilute NaOH2, dilute KOH, and so on. Children, let us discuss based on the degrees of ionization. The degree of ionization of bases in a solution can be used to classify them. It's also known as foundation of strength. When dissolved in water, it produces a certain quantity of hydroxyl ions. The degree of ionization distinguishes two types of bases. One is strong base, second one is weak base. The strong base is one that associates entirely or to a large extent in water. For example, NaOH, KOH, and strong bases. Weak bases. A weak base is one that does not dissolve entirely or only dissociates to a very little level. For example, NH4OH and other are the weak bases. Children, let us discuss the uses of bases. Bases have various uses. From the important uses of the bases are calcium hydroxide. Calcium hydroxide is used to neutralize acidity in the soil. Calcium hydroxide is a vital ingredient in mortar and whitewash. It is an essential component of the borax mixture, which is used to protect agricultural crops from pests. Hydrochloric acid is also used to prepare dyes mixes for painting. Bleaching powder is also made from CaOH2, commonly known as calcium hydroxide or slaked lime. Sodium hydroxide. Sodium hydroxide is used in the production of detergent, textiles, and paper. Sodium hydroxide is used in households for unblocking drains. Sodium hydroxide is used in the making of paper and soap. Sodium hydroxide is also utilized in the production of rayon. Ammonium hydroxide. Ammonium hydroxide is used as a reagent in laboratories. Ammonium hydroxide is also used to manufacture plastics, dye, rayon, etc. In laboratories, ammonium hydroxide is a critical reagent. Slaked lime can be used to utilize any excess acidity in soil. Magnesium hydroxide. Magnesium hydroxide is popularly known as milk of magnesia, is a laxative intensively used. It is also used as an antacid since it decreases excess acidity in the human stomach. Children, let us discuss about alkali. Bases are easily dissolved in water are called alkali. In other words, water soluble bases are also called alkali. Children, let us discuss the difference between alkali and bases. Alkali. Water soluble bases are called alkali, bases that they do not dissolve in water. Next come to all alkalis are bases and all bases are not alkali. Then come to the alkali. Alkali releases OH ions on dissolving in water. They are also proton acceptors. Come to the base. Bases are neutralize the acidity in an acidic base neutralization reaction. Examples of alkali are potassium hydroxide, sodium hydroxide. Examples of bases are zinc hydroxide and copper hydroxide. Children, now let us discuss the addition of acids or bases to water. The process of dissolving an acid or a base in a water is highly exothermic. As this reaction usually generates a lot of heat, so there must be exclusive care taken while mixing the concentrated acids with water, especially when nitric acid or sulfuric acid is mixed with the water. Rules: the acid must be added slowly to the water with continuous and constant stirring. Otherwise, it can be cause the mixture of flush out, which in turn causes burns. Children, the glass container may also break due to excessive heating, which can cause damage. When an acid or a base is mixed with water, it results in dilution. It decreases the concentration of ions per unit volume, thereby easily dissipating the effect of heat. Children, let us discuss about ionization and dissociation. Dissociation is the separation of ions from an ionic crystal when a solid ionic compound dissolves in water. On the other hand, ionization is the process where a neutral molecule breaks into charged ions when dissolved in a solution. The extent of ionization depends on the strength of the bonds between ions and the extent of solvation of ions. The three most important modern concepts of acids and bases, let us discuss what are they. Arrhenius concept. According to Arrhenius concept, substances which produced H plus ions when dissolved in water are called acids, while those which ionize in water to produce OH ions are called bases. Arrhenius proposed that acid-base reactions are characterized by acids if they are dissociated in an aqueous solution to form hydrogen ions, and bases if they form hydroxide ions in an aqueous solution. Children, now let us discuss about Arrhenius' theory of acid and base. What is acid, what is base, and the difference between acid and base? These questions are nightmares to chemists in the earlier 15th and 16th centuries. To solve these questions, a chemist named Arrhenius came up with a theory called Arrhenius theory. According to Arrhenius theory, a substance that gives H plus ions in its aqueous solution is called acid, whereas the substance that ionized OH minus ion in an aqueous solution is called bases. He proposed that Now let us discuss the limitations of Arrhenius concept. The presence of water is absolutely necessary for acids and bases. Dry HCl cannot act as an acid. HCl acts as an acid in water only and not any other solvent. The concept does not explain the acidic and basic character of substance in non-aqueous solvents. The neutralization process is only possible for reactions which can occur in an aqueous solution. Although reactions involving salt formation can occur in the absence of a solvent, the acidic character of some salts such as AiCl3 in aqueous solution can not be explained. An extent as well as artificial explanation is needed to define the basic nature of NH3. Children, now let us discuss about Bronsted-Lowry concept. The Bronsted and Lowry in 1923 independently proposed a more general definition of acids and bases. According to them, an acid is defined as any hydrogen containing material, molecule, ion or a cation which can be donated a proton to other substance, and a base is any substance that can accept a proton from any other substance. Therefore, acids are proton donors where bases are proton acceptors, according to their theory. Children, according to conjugated acid bases pairs are considered, the reaction is acid 1 plus base 2 gives to acid 2 and base 1. In this reaction, HCl donates a proton to H2O and is therefore an acidic. Water, on the other hand, accepts a proton from HCl and is therefore a base. In the reverse action, which at equilibrium proceeds at the same rate as the forward reaction, the H3O ions donate a proton to Cl ion, hence H3O plus an ion is an acid. Cl minus ion, because it accepts a proton from H3O ion, is a base. Acid-base pairs in which the number of reactions can be formed from each other by the gain or loss of protons are called conjugated acid-base pair. Children, let us discuss about Bronsted-Lowry theory of acid and base in detail. The Bronsted-Lowry theory also provides an explanation of acid and base. According to this theory, acid is an ion H1 and proton donor, and it forms its conjugated bases, whereas the base is substance that accepts an H plus ion or a proton to form conjugated acid. According to Bronsted-Lowry, acids are substances that donate a proton or H plus ions to the other compound. Examples: conjugated base. Bronsted-Lowry base is, according to Bronsted-Lowry base, are the substances that accept a proton or H plus ion from other compounds. Base plus proton conjugated acid. Children, let us discuss the limitations of Bronsted-Lowry concept. The Bronsted-Lowry could not explain the reaction occurring in the non-protonic solvent like COCl3, S2O, N2O4, and the basic oxides like which can easily take place in the absence of solvent, as well substances like BF3, AlCl3, etc. do not contain hydrogen, which means they cannot donate a proton. Still, they behave as acids. Children, now let us discuss about Lewis concept. According to Lewis' theory of acid-base reactions, bases donate pairs of electrons and acids accept pairs of electrons. Thus, it can be said that a Lewis acid is an electron pair acceptor. The advantages of Lewis' theory is that completely the model of oxidation reduction reactions. The oxidation reduction reactions takes place on the transfer of electrons from one atom to another with a net charge in the oxidation number of one or more atoms. The Lewis theory further suggested that acids react with bases and share a pair of electrons, but there is no charge in the oxidation number of any atoms. Either an electron is transferred from one atom to another, or the atoms come together to share a pair of electrons. Like aluminum hydroxide is acting as a base, and another example is aluminum hydroxide is acting as an acid. These reactions are showing clearly when aluminum hydroxide accepts proton, it acts as a base. When it accepts an electron, it acts as an acid. This Lewis acid-base theory also explains why non-metal oxides such as carbon dioxide dissolved in H2O to form acids, such as carbonic acids, as example is given below. Now let us discuss the limitations of Lewis theory. The Lewis concept gave a generalized idea including all coordinations, reactions and compounds. This is not true always. An idea about the reactive strength of acid and bases is not provided by Lewis concept. The Lewis concept is not in line with the acid-base reaction concept. Lewis concept has not discussed the behavior of proton acids like HCl. Children, now let us discuss how do acids and bases react with metals. An important part of acids and bases and salts in class tends to find how they react with metals. When acids react with metals, they release hydrogen gas and to create a compound called salt. Acid plus metal is equal to hydrogen gas plus salt. When base reacts with metal, they release hydrogen gas and produce salt. When sodium hydroxide reacts with zinc metal, then it releases sodium gas and gives sodium zincate. Children, let us discuss how metal carbonates and metal hydrogen carbonates react with acids. We now move on to understand the reaction of metal carbonates and hydrogen carbonates with acids, bases and salts. Class 10. All the metal carbonates and metal hydrogen carbonates react with acids to produce its corresponding salt, carbon dioxide and water. The metal carbonate, metal hydrogen carbonate plus acid, salt, carbon dioxide plus water. For instance, when sodium carbonate is mixed with hydrochloric acid, it produces sodium chloride plus carbon dioxide plus water. Children, let us discuss how do they react with each other. When an acid reacts with a base, they tend to nullify each other's effects. This is called neutralization reaction because both substances have neutralizing effect on each other. A reaction between an acid and a base results in the production of salt and water. Acid plus base is equal to salt and water. For instance, when sodium hydroxide is diluted with hydrochloric acid, then it gives to sodium chloride and water. Children, let us see what happens when metallic oxides react with acids. When metallic oxide, also called basic oxides, react with acids, they nullify each other and gives rise to its corresponding salt and water. For instance, if copper oxide is diluted with hydrochloric acid, the solution turns bluish green in color and result in the formation of copper 2 chloride along with water. Children, let us see what happens when non-metallic oxides react with bases. When non-metallic oxides are acidic in nature, which means that when a base reacts with non-metallic oxide, it nullifies the effect and produces salt and water. When calcium hydroxide base reacts with carbon dioxide, non-metallic oxide, it produces salt and water. Children, let us see what is the common between all acids, all bases and what happens to the two when dissolved in water solution. Yes, all acids contain hydrogen gas which is released when an acid comes in contact with metal. When acids are dissolved in water solution, they tend to dissociate hydrogen ions, hydrochloric acid. When dissolved in water, it gives hydrogen ion H plus and chloride ion Cl minus. All the bases tend to generate negative hydrochloride. All the bases tend to generate negative hydroxide OH minus ions in water. Not all the bases are soluble in water. That ones that are soluble, they are called alkalis. They are soapy, bitter and corrosive in nature and can also be harmful. Children, let us discuss the strength of acids and bases. The strength of an acid or a base is measured by the amount of H plus ions or OH minus ions present in their aqueous solution. Strong acids have a higher concentration of H plus ions per unit volume in their aqueous solutions, whereas weaker acids have a lower concentration of H plus ions per unit volume in their aqueous solutions. When an example of a strong acid H2SO4 and as an example of a weak acid is CH3OOH. Similarly, strong bases have a higher concentration of OH minus ions per unit volume in their aqueous solutions, where weaker bases have a lower concentration of OH minus ions per unit volume in their aqueous solution. An example of a strong base is KOH and as an example of a weak acid is CaO. The strength of acids and bases can easily measured by using pH scale. Children, now let us discuss what is pH scale. pH stands for potential of hydrogen and it is defined as logarithm of H plus ion concentration. The pH value of any substance or solution indicates whether it is acidic, neutral or alkaline. The term pH was first introduced by Soren Peter, biochemist in 1909. To determine the strength of acids and bases, we use a universal indicator that shows different colors at different concentrations of hydrogen ions in a solution. The value of pH is generally used to quantitatively determine the strength of acid and base. The equation used for the calculating pH is pH is equal to log H plus ions. Children, let us discuss in detail what is this pH value. To find the pH value of a component, we use a pH scale. The pH scale has values from 0 to 14, where 0 indicates very acidic and 14 indicates very alkaline. 7 is the center of the scale. If any solution has pH value of 7, it means that the solution is neutral in nature. The values less than 7 indicates that the solution is acidic, and values more than 7 that the solution indicate alkaline. pH is used to measure the basicity and acidity of a solution. The amount of hydrogen ions concentrated in a solution determines the pH. Mathematically, it gives a formula of pH Log plus H. Already we discussed that. The pH scale is used to measure the relative acidity and alkalinity of solutions. The neutral pH value depends on the temperature. It can be lower than 7 if the temperature increases above 25 degrees centigrade. Children, let us discuss the pH indicator. An indicator that determines whether a solution is acidic or basic is known as a pH indicator. Generally, the indicator causes the color of solution or a paper to change depending on the pH value. There are different types of indicators. Some are solid and some are liquid in nature, but most of the common indicators are found in the form of strips or a paper. Strips of paper, known as litmus paper. It changes its color to red when added to an acidic solution and gives a blue color when tested with a basic solution. Also, there are various other ways to make indicators at home. Indicators. Children, already we discussed about indicators that are chemical compounds which help to indicate the presence of acid or base in the chemical reaction. They process different colors in acidic solutions and different colors in basic solutions. Indicators are made naturally by plants and animals or artificially by humans. The image of litmus test of acids as shown as in beside picture. An indicator indicates the pH ranges from range of 0 to 7 indicates that acidic solution. The range of 7 to 14 indicates that basic solution, and 7 is a neutralized solutions. Children, types of indicator. There are various types of indicators used for various purposes, of which are, for example, natural indicators. Indicators derived from plants and animals or any living organisms are natural indicators. Examples: red cabbage, litmus paper, and others. Synthetic indicators. Indicators made artificially in laboratories and factories are synthetic indicators. Examples are phenolphthalein, methyl orange, and others. Olfactory indicators. Substances that have different smells in acidic or basic mediums are called olfactory indicators. Examples: onions, olives, and others. Children, let us discuss the importance of pH in our everyday life. Let us discuss about digestive system. In human body, all the physiological reactions takes place at one pH of 7 to 7.8. Hydrochloric acid is secreted as food enters the stomach, turns to pH of stomach between 1 and 3 because of overeating of various reasons. Excess of HCl, hydrochloric acid, is released. The excess of HCl in the stomach causes indigestion, which produces pain and irritation. To cure indigestion, we can take bases called antacids. Antacids are a group of mild bases. Being basic in nature, they react with excess acids in the stomach and neutralize it. Common as antacids used for curing indigestion due to acidity are milk of magnesia, means magnesium oxide, and baking soda, etc. Children, let us discuss the importance of pH in tooth decay. When we eat food, the bacteria present in our mouth breaks down the sugar to form acids. The acid lowers the pH in the mouth, making it acidic. When the pH of mouth falls below 5.5, our tooth starts decaying. Tooth decays happens because the acid becomes strong enough to attack the enamel and corrode it. The best way to prevent tooth decay is to clean the mouth thoroughly after eating food. Many kinds of toothpaste containing bases to neutralize mouth acid means the pH of toothpaste being about 8.0. So we using toothpaste for cleaning the teeth can neutralize the excess of acid in the mouth. Children, let us discuss the plants and animals are sensitive to pH changes. Yes, most of the plants grow best when the pH of soil is close to 7. If the soil is too acidic, then it is treated with quicklime, means calcium oxide, slaked lime with calcium hydroxide, and chalk calcium carbonate. If the soil is too alkaline, then it can be reduced by adding manure or compost, which contains acidic materials. The pH also plays an important role in the survival of animals, including human beings. The aquatic animals can survive in water bodies within a narrow range of pH change. The high acidity of water bodies can kill aquatic animals. Calcium carbonate is often added to acidic lake water to neutralize the acid that comes from acid rain. Children, let us discuss the self-defense by animals and plants through chemical warfare. When a honeybee stings a person, it injects formic acid into the skin. By rubbing a mild baking soda neutralizes the acidic liquid injected by a bee sting. When a wasp stings, it injects a alkaline liquid into the skin, causing burning pain. By rubbing mild acid vinegar on the sting area gives relief. When a person touches the leaves of a nettle plant, the string hair of a nettle leaves injects methanoic acid into the skin. It can be neutralized by rubbing baking soda or duck plant, which gives beside the nestle plant and is basic in nature. Lime juice to clean copper vessels. Children, a dull green colored forms on a copper vessels when it is exposed to damp air over an extended period of a time. Copper hydroxide and copper carbonate are combined to form this greenish layer, and the reaction is as follows. Because of these goods are basic in nature, acidic substances such as lemon or tamarind juice are required to clean them. These sour components are chosen for cleaning since they are good at cleaning copper vessels. Children, let us discuss the properties of acids, bases, and salts. The acid, bases, and salts affect chemistry as well as our day-to-day life. They can be easily identified by their taste, that it is acids taste sour and bases taste bitter, and salt themselves have salty taste. Acids are usually found in many substances including various food items, but their presence in many fruits is very prominent. For example, a part of this there are some acids which are widely used in the laboratory like hydrochloric acid, sulfuric acid, nitric acid. Usually bases are found in household cleaners only to clean grease, form the window and the floors, and it also found in soaps, toothpaste, egg whites, dishwashing liquids, and household ammonia. Our body contains some very common acids in stomach like diluted hydrochloric acid, which causes food indigestion. When the contents of our stomach become too acidic, we usually get indigestion and a burning sensation in our stomach. Acids and bases are also regulate some metabolic activities in the human body through the process of equilibrium. Bee string are acidic in nature while the swamp strings are alkaline in nature. All acids when react with metals generate hydrogen gas. Hydrogen is usually common to all acids. Children, now let us discuss about salts. Apart from sodium chloride, other common salts are sodium nitrate, barium sulfate, etc. Sodium chloride or common salt is a product of reaction between the hydrochloric acid, it is an acid, and sodium hydroxide, it is a base. Solid sodium chloride is made of a cluster of positively charged sodium ions and negatively charged chloride ions held together by electrostatic forces. The electrostatic forces between positive charges are inversely proportional to the dielectric constant of the medium. In other words, we can say that a compound that has acidity in its nature and a compound that has basicity in its nature may yield salts when combined together. The universal solvent water has a dielectric constant of 80. Therefore, when sodium chloride is dissolved in water, the dielectric constant of water reduces the electrostatic force and allowing the ions to move freely in the solution. They are also well separated due to hydration with water molecules. Children, let us discuss in detail about what are salts. When an acid and a base react to neutralize one another, they generate salts which are ionic substance. Salts do not have an electrical charge. Salts come in a variety of forms, the most common of which is sodium chloride. Table salt and common salt are the both terms of sodium chloride. Sodium chloride is used to make dishes taste bitter. Children, let us discuss the physical properties of a salt. Salts have various physical properties, and some of the following physical properties of salt are: in nature, the bulk of salt is crystalline. Salts that are transparent or opaque are available. The bulk of salt is soluble in water. Salt solution is in their molten state also transmit electricity. The flavor of a salt can be salty, sour, sweet, bitter, or umami. In nature, there is no odor to neutral salts. Salts that are colorless or colored are available because it contains ions. Salt water is an excellent conductor of electricity. Electrostatic attraction holds the ions together and a chemical bond is established between them. Salts are formed by the combination of acid and base through the neutralization reaction. The acidic and basic nature of salts usually depends on the acid and base from which the salt evolved in neutralization reaction. For example, NaOH plus HCl give to NaCl plus H2O, and HCl plus NH4OH gives to NH4Cl plus H2CH3COOH plus NaOH gives to CH3COONA plus H. CH3COOH plus NH4OH gives to CH3COONH4 plus H2O. The most well-known or common salt is sodium chloride or table salt, which is formed by the combination of a strong base sodium hydroxide and strong acid hydrochloric. Other examples include Epsom salt, MgSO4, which is used in bath salts. Ammonium nitrate is used as fertilizer. Baking soda is used in cooking. The pH of solution of salt also depends on the strength of acids, bases, which are combined in the form of neutralization reactions. Children, let us discuss the types of salts. Salts are categorized into various categories. Some of the important categories are given below: acidic salt, basic or alkali salt, and neutral salts. First, let us discuss about acidic salt. A partial neutralization of a diprotic or polyprotic acid produces an acidic salt. These salts contain H plus cations in their aqueous solutions. The ionizable H plus makes the majority of the ions. Some examples of acidic salts are NaHSO4, KH2PO4, etc. These salts are formed by the neutralization of strong acids and weak bases. Ammonium chloride. Ammonium chloride is formed when hydrochloric acid is a strong acid, interacts with ammonium hydroxide with a weak base, means NH4OH plus HCl gives to NH4Cl plus H2O. Ammonium sulfite. Ammonium sulfite is formed when ammonium hydroxide, a weak base, react with sulfuric acid, means with a strong acid. Base or alkali salt. A basic salt is formed when a strong base reacts with a weak acid to partially neutralize it. When they are hydrolyzed, they decompose into a basic solution. This is because when a basic salt is hydrolyzed, it produces the conjugated base of weak acid in the solution. Examples of sodium carbonate and sodium acetate. Sodium carbonate. Sodium carbonate is formed when a sodium hydroxide strong base reacts with carbonic acid. And sodium acetate is formed when a strongly base sodium hydroxide reacts with acetic acid. Children, now let us discuss about neutral salts. Salts generated by the reaction of a strong acid with a strong base are neutral in nature. The pH of this salt is 7, which is considered neutral. Potassium chloride, sodium chloride, and other are the examples of neutral salts. Children, let us discuss about sodium chloride. Sodium chloride is formed when hydrochloric acid mixes with sodium hydroxide and sodium sulfate. It is made by sulfuric acid combines with sodium hydroxide, means a strong base with a strong acid. Salts can also be categorized into other two categories, including mixed salt and double salt. First, let us see what is double salts. Salts with more than one cation or ion are known as double salts. They are created by mixing two different salts that crystallized in the same ionic lattice. For example, potassium sodium tetrate are also known as Rochelle salt. Mixed salts. Salts which are produced by mixing two salts which generally share a common cation or anion are mixed salts. Example, bleaching powder. Children, let us discuss what causes the formation of acidic, basic and neutralized salts. The causes of the formation of acidic, basic and neutralized salts are discussed below. When a strong acid reacts with a weak base, the base is unable to completely neutralize the acid. As a result, a salt that is acidic form. When a strong base is combined with a weak acid, the acid is unable to completely neutralize it. As a result, you get a simple salt. When an equal strength acid and a base react, they totally neutralize each other. A neutral salt is formed as a result of this process. Children, let us discuss some of the common salts. Salts are chemical compounds that are formed as a result of neutralization reactions between acids and bases. When we hear salt, we only think about common salt, which is sodium chloride, that we eat in our daily life. But there are several other salts also which are widely useful. In this lesson, you will learn about some common salt is widely used like baking soda, sodium bicarbonate, washing soda or sodium carbonate, bleaching powder or calcium hydrochloride. Children, let us discuss about baking soda. Baking soda is also called sodium hydrogen carbonate. Is a chemical compound whose chemical formula is NaHCO3. Baking soda has a sodium ion Na plus and a bicarbonate anion HCO3-. Sodium bicarbonate is a white crystalline powder and, as the name suggested, is used for baking. Let us see the details of baking soda. The chemical name of baking soda is sodium hydrogen carbonate. Formula is NaHCO3. Preparation of baking soda can be prepared with the help of the reaction given below. NaCl plus NH3 plus CO2 plus H2O and gives rise to NaHCO3 plus NH4Cl. Let us discuss the uses of baking soda. A few of the uses of baking soda are: it is used as an anti-acid in the case of acidity. It is used for baking purposes. It is also used as a water softening. Children, now let us discuss about washing soda. Washing soda, also called sodium carbonate, is a chemical compound whose chemical formula is Na2CO3. Washing soda has two sodium ions Na plus and carbonate anions CO 32 minus. Sodium carbonate is a white crystalline powder and, as name suggested, is used for washing purposes. Let us see the details of washing soda. Washing soda chemical name is sodium carbonate. Formula is Na2CO3. Uses of washing soda are: it is used in a glass, soap and paper industries. It is used as washing powder also. Children, now let us discuss about bleaching powder. Bleaching powder, also called calcium hypochlorite, it is a chemical compound whose chemical formula is CaOCl2. Bleaching powder is used for bleaching purposes in its aqueous solution. Bleaching powder releases chlorine, which is responsible for bleaching action. Let us see the details of bleaching powder. The chemical name of bleaching powder is calcium hypochlorite. Chemical formula is CaOCl2. Preparation of bleaching powder can be prepared with the help of the following reaction, that is CaOH2 plus Cl2 gives rise to CaOCl2 plus H2O. The uses of bleaching powder are: it is used for bleaching the laundry, it is used as an oxidizer in many industries, it is used as an disinfectant to clean water. Children, now let us discuss the crystals of salts. Some salts combining with water form crystals, and these water molecules are required to form crystals are called water of crystallization. Some examples of crystal salts are table salt, sodium chloride crystals, sugar, sucrose crystals, etc. Children, now let us discuss about plaster of Paris. Plaster of Paris is also a widely used chemical compound for various purposes such as sculpting materials, gauge bandages, building and furnishing houses and others. Plaster of Paris is hydrated calcium sulfate obtained by calcining. It is a white powdery chemical compound. The details comes for plaster of Paris. Chemical name is calcium sulfate hemihydrate. Chemical formula is CaSO4 1 by 2 by H2O2. Preparation of plaster of Paris can easily prepared with the help of the following reaction given below. CaSO4 plus H2O, heating at 100 degrees centigrade, it gives rise to CaSO4 half H2O plus half H. Thank you. Thank you.